Okay, so what we want to do is look at two special triangles to evaluate some special trig ratios of given angles. We're going to start with our first triangle, but to get there I want everyone to draw a square on your page. Looks like this. Okay. And we're going to draw a diagonal through the square, like that. We're going to label each side length 1. This is 90 degrees, and because we're splitting the 90-degree angles in half, that's going to be 45 degrees, and that's going to be 45 degrees. So what we're going to do is isolate the part of the square that we want to focus on, and that's this special triangle that we've created here. So I'm going to redraw it. Okay. There's 90 degrees, here's 1, here's 1, there's 45 degrees, there's 45 degrees. What we want to do is find this side length. Well, this is a 90-degree angle triangle, so we can use Pythagorean's theorem. 1 squared plus 1 squared is equal to c squared. Here's c. You can clean this up a little bit. 1 plus 1, 2 is going to be equal to c squared. We're going to take the square root of both sides. That'll cancel out that power of 2. And we end up with c equaling the square root of 2. I'm not going to express that as a decimal. We're going to keep that as a radical number. We'll leave that there. So now what you're going to do is evaluate the sine, cos, and tan and here I've written theta. So sine theta. Well, what angle are we looking at? These are special angles. So the angle we've created here is 45 degrees. So these three are going to all be evaluating the angle that's 45 degrees. Tan 45 degrees. So look at your triangle. Let's write out the ratios for these three special angles that are 45 degrees. So you can look at either angle, it doesn't matter. The sine of 45. The sine of 45 is opposite over hypotenuse. So this is going to be 1 over the square root of 2. Now I want you to fill in the other ones by yourself, and I'm going to show you a little trick that we do here to get rid of this radical in the denominator. We're going to multiply both the top and the bottom by this ratio. Remember, this is going to equal 1, so we're not changing the ratio. But if we multiply across, the numerator is going to become root 2, and the denominator, those square roots are going to cancel out, and we end up with 2. That's called rationalizing the denominator. We don't like to have a radical number in the base. So if we multiply by that radical, we end up with a cleaner version of our special angle here. So the sine of 45 is root 2 over 2. I want you to finish off by doing the cos and the tan of 45. Make sure you don't keep a radical in the denominator. Rationalize like this. When you're done watching this, you can head back to the regular page and read for the next instructions.